Good evening, everyone. So, today we are going to start a new chapter. So, we begin with Pigeonhole Principle. So, principle is very easy, but you will be able to see that it can be helpful in solving very difficult problem. So, it says that if you distribute n plus 1 objects into n boxes, then of course there would be at least one box containing two or more objects. So since n boxes are there, the worst case is you put one object in one box, so all n boxes are filled now with one object, and n plus 1th object would go into any one of the box. That's why there would be at least two objects in one of the box. So it means that among 13 people there are always or at least two having their birthdays in the same month. Similarly, if there are n married couples, then how many of the 2n people must be selected to guarantee that a married couple has been selected? Yes, so again the answer is n plus 1 using the pigeonhole principle. Now let's see some interesting questions. The first one says that m integers are given and there exist integers k and l such that ak plus 1 plus ak plus 2 plus al is divisible by m. First, let's try with some example. For example, randomly write down any numbers 11, 5, 6, 8, 4, 2, 1. 7 numbers are there. So it means that there must exist consecutive numbers. For example, here 8 plus 4 plus 2. So 14, which is divisible by 7. So it is always possible. Yes. And it does not mean that you consider any sequence, for example 5 plus 6, and it is divisible by 7. No. So there exists a sequence of consecutive numbers which is divisible by m. Now we have to see how can we prove it using pigeonhole principle. So if I have these m numbers are there, then I can have m sums a1, then a1 plus a2, and in the last a1 plus an. If any of these sum is divisible by m, then we are done. It means assume that none of them is divisible by m. So none of them is divisible by m. What does it say? If none of them is divisible by m, means each one when you divide by m, there must be a remainder. Yes. Now what could be the values for the remainders? So if I denote remainder by r, then the values could be 1, 2 till m minus 1. Yes. Now try to think how pigeonhole principle would come into the picture. There are m sums, r remainders. It means that there must be at least two sums having the same remainder. Yes, m sums are there, m minus 1 remainder. So using pigeonhole principle, there must be at least two sums. So one is a1 goes till a k a l, and you can write it as b m plus r, you can write it as c m plus r. Yes, so both have the same remainders. Now since both have the same remainders, if you subtract one from the other, then it would be ak plus 1 so on till al should be c minus pm. It's clearly you found a sequence which is divisible by m. So let's try one more question based on pigeonhole principle. Consider the integers from 1 to 200. Among them choose 101. Now among the chosen there are two such that one of them is divisible by the other. Yes, so again you have to use the pigeonhole principle. You have to see why this 101 is given. For example, from 1 to 200, there are 100 even numbers, 100 odd numbers. Yes, and 101 is there, so there may be the repetition of odd numbers or even numbers, something like this. So you have to form some set, something like this. Yes, so think over it how you can prove it. Now, one idea is that how do you represent each of the numbers, either in terms of odd or even. So I can say that I can represent any integer in the form of 2 raised to the power k multiplied by a, where a is odd. You can try any one of them, 2, 3, 4, 5. You can always write it in this form, because like 13 is there, you can do it 2 raised to the power 0. Yes, so k is greater than equal to 0. Now think how do you use the pigeonhole principle. You are choosing 101 integers, but among the numbers 1 to 200 there are only 100 odds. It means there are two integers for which a is same. So there are two integers, one let's say 2 raised to the power k cross a, and other 2 raised to the power r cross a. Yes, because you have to choose 101. So when you choose 101 integers and when you write each one of them as 2 raised to power k multiplied by a, now at most 100 a can be distinct. But 101 integers are there, so there would be at least two integer where when you write in the form of 2 raised to power k multiplied a would be same. So now let's say one is 2 raised to the power 4, one is 2 raised to the power 5 or 6 multiplied by a, so clearly one is divisible by the other. Let's try one more question. SB set of 27 distinct positive odd integers less than 100. Prove that there exist two elements in S whose sum is 102. Yes. So to begin with, try to see that different combinations where distinct odd integers having sum 102. Yes. So for example, the possibility could be 399, then 597, and it goes 49 and 53. Yes, other than that, first see how many pairs are there. These are 24 pairs. Yes, now if I pick only one number from each pair, so for example I make a set 3, 5, 7, so on 49. So these are 24 numbers are there, and for sure their sum is not 102, but I have to find 27. So in that set the possibilities I can add 1 and 51. So 1 and 51 was not there forming the pair because 1 plus 101 is 102, but it is 1 plus 101 and the other is 51 plus 51 is 102. So I need the distinct. So but in that set I can add 1 and 51. Now if the set is 1, 3, 5, 7, 49, 51, still there are 26 numbers and there is no two elements whose sum is 102. But I have to find 27. This is the pigeonhole principle. It means the next number, because each one need to be distinct, should be the second number from these pairs, and that second number would give you two elements in S whose sum is 102. So very interesting question. Think over it. This is comparatively difficult than the previous questions. It says that a chess master who has 11 weeks and he plays at least one game every day and decided not to play more than 12 games during a week. Show that there exist consecutive days. So these consecutive days can be 3, 4, 5, any, but consecutive days must be there, where the chess master must have played exactly 21 games. So again, if you see this one, and let's use some notation. So let's say I say a1 be the number of the games played on first day, a2 be the number of the game played on first and second, and so on. Yes, and total 77 days are there. So that's why I have a sequence a1, a2, a77. But the question comes that what need to be proved first? Yes, so I need to prove that if ai and aj are there, then ai minus aj, assuming I is greater than j, should be 21, or ai is equal to aj plus 21, because ai is the number of the games played on first, second, third till ith day, j is till jth day. It means if I prove ai minus aj is equal to 21, then on j plus 1th day, j plus 2th day till ith day, consecutive days, they will play exactly 21 games. This is one information. The other information is that maximum in these 7 weeks he can play 11 into 12 games. So 1 is less than a1 is less than a2 is less than a77 is less than equal to 132. Yes. Now this sequence is nowhere close that we can use the pigeonhole principle. This 132 comes because 11 multiplied by 12. But at the same time, I need something like this. ai is equal to aj plus 21. It means if I form one more sequence, so 1 plus 21, a1 plus 21, so on, a77 plus 21, and 132 plus 20. So now I have two sequences. Now how do you use the pigeonhole principle? Spend some time, think over it. So if I consider the total numbers, then this is 77 plus 77, which is 154, and all these numbers are lying between 1 to 153. So if I write down these numbers, a1 plus 21 and a77 plus 20, all these numbers are from 1 to 153, and 154 number are there. It means two numbers must be same. Now from a1 to a77, it is not possible two numbers can be same. It's strictly increasing sequence because we play at least one game on every day. Similarly, in this set also no two numbers can be same. It means one from this and one from this need to be same. So if I pick ai from this and aj plus 21 from this, then they must be equal. And this is what we are looking for. So that's all from today's class. In the next class, we will introduce the concept of Ramsey number. Thank you.